Welcome, everyone. Thank you for listening in to our first webinar on Halo, the wireless cabin air quality monitoring system. While IP Video has been designing, developing, building, and selling thousands of these units to the schools, universities, commercial building markets, today marks L2's introduction of Halo for aerospace applications. Our intent today is to introduce, to educate, and hopefully spawn questions from you, our audience. So please send in questions to our team so we may answer them afterwards. And last but never ever least, the least important, we sincerely hope that all of you are safe, that you're healthy, and you see a light at the end of this pandemic tunnel we have been stuck in. Thank you for participating today. Let's get started. Today's participants are Mark Lebovitz, the founder and president of L2 Aviation, an aerospace systems integrator for over 20 years. From IP Video, David Antar, founder and CEO of IP Video, 24-year-old network-based video-centric technology company. And Frank Giacovino, the Halo technical guru and the vice president of product development for IP Video. My name is Mike McConnell. I've been leading the JV between L2 and IP Video and providing some business development for Halo in the aerospace markets. I will be the moderator of today's webinar. Let's jump right in with Mark leading us off on the Halo for aerospace markets. Mark, take it away.
Hi, Mark. I think you're on mute.
I could fix that now. Thank you very much, Danielle. Well, thanks, Mike, and thanks for everybody else joining us today. In case you're not familiar with L2 Aviation, this slide is meant to educate, not really provide you an in-depth, sales-oriented testament of what we've done. But we do want to share, we've been in business for 23 years. We have almost every major airline as a customer of ours, and we've had significant growth over the last couple of years. Even these COVID times, we're seeing new business contact us all the time about delivering avionics and systems integration. Yet Halo is our first L2 branded product. We're quite proud of that. We're extremely excited to be part of this journey to help our customers and to create a safer cabin environment. Next slide, please. And this is just kind of an overview, but this is our biggest project to date. We're quite proud of it as well. It was a Collins large format display system. They call it LDS. And this particular one was for a 757 and 767, where we moved 28 and installed 11 with 5 unique part numbers. So quite a bit was removed, and then we went back in with the newest technology. But getting those big and small items to fit, ending up with a clean installation to meet multiple parties' requirements was challenging, yet very successful. So L2 is capable of doing both large and small modifications, and full fleet programs are not new to us. We're going to apply our nose to tail certification experience to roll out Halo for a variety of integration options. Next slide, please. So we all know what's happening today, and it's tragic. It's awful. There's a pandemic, and people are dying, and sadly causing worldwide deaths. It seems like every day there's more and more of that. We want that to be resolved. But the second order of all this is the decline in the demand for so many businesses and the economic pain it is inducing. None seem to have been hit harder than the airlines themselves and travel industry specifically. The airlines today simply have to find a way to get back into business. They have to get people traveling. They need them to feel safe on their aircraft. And anything that we could do to help that, and if it's contributing by having a safer cabin, whatever we could do there with data alerts, we have to measure the cabin. And Halo can measure what's in the cabin today. And we're taking the exciting, award-winning, and proven Halo product for commercial buildings and developing it for aerospace, along with the FAA, and then with certification authorities all over, worldwide. With baseline cabin air data, you could finally measure what's in your cabins, and then you could pivot as you need the conversation to your airplane's health and the promise of the healthiest cabins in the world. Next slide, please. So problem statement. Every engineer likes a problem statement, and I'm no different. The problem statement as we see it is there's nothing in an airplane today, installed or portable, that can capture what is truly in the cabin air in all areas of the fuselage, flight deck to the lavs, to the galleys, to the cargo areas. So what if we could show what is floating around to include the really bad elements? For instance, carbon monoxide, carbon dioxide, ozone, a variety of things. Then when there's a fume event, and that's kind of a common term amongst the airlines, where it could be a breakdown of products, it could be just anything from the engines, like oil being overheated through the trim system or through the bleed air system. And now you have empirical data to either take action or make a decision to keep an asset in service, or even better, no longer divert in flight because of an unknown or unquantified air quality issue. We're also looking at how to apply HALO's ability to detect small, minuscule, really small differences in air pressure between multiple remote HALO sensors. So now there's a way to alert a depressurization issue and process prior to what's available with current installed technology. So HALO has experienced much of this early success in schools, and we're leveraging that. And its unique ability to do the detection of vaping, to include THC for those so inclined. And Frank and David will explain a little bit more later about the capabilities of the specific system itself. Next slide, please. So here's some quotes, and these were captured directly from a Flight Attendants Union website. A lot of information here, but what you could see is that they really take cabin air seriously, and they work directly with Washington, D.C., to solve problems they can't really solve at the carrier level. At least they don't believe they could solve at the carrier level. And the aircraft manufacturers either don't like or apparently don't agree with a lot of the cabin crew concerns or claims based on some problem with the bleed air or air cycle design or system. However, it appears it is a real problem. There's a lot of examples when you just Google it on the web. And there's the health data to back up the flight attendants' claims. Their data seems to be true. We don't have enough information to prove it, but there's enough of it that it makes us think that there is an issue, hence the problem statement. And we notice their language at the bottom speaks about a lack of training on fume events. They really further the need for some device, an automated system of some sort, of measuring cabin air quality and then alerting the onboard crew appropriately so they can take action as applicable, either in flight or hopefully more proactively on the ground before the issue gets worse. Next slide, please. Smells in the cabin. Well, we found out these meetings actually do occur, and we learned this out when we were originally doing research about options for cabin air. And the original industry conversations meant that they had an issue, and they talk about it a lot. Now, while not naming the carrier, it was quite interesting. There is enough concern about odor events, so much that the unions have asked for a forum with the airline's environmental systems engineers, and they're using that to investigate the odor, the occurrences, where do they come from, why, what can they do. And just want to kind of add before we move on that I don't think they really call it the smelly committee. It's just something that we just thought it fits. So we have named it the smelly committee internally. Next slide, please. Real world problems for airlines. So here we just want to cover some real evidence of cabin air problems. There's been quite a few over the years. Some of you may have been part of these investigations or maintenance fixes. It'd be kind of interesting to reach out to us if you had. We'd like to get more data. Not all the airlines like to share this type of internal information. But what we can find is available, public information. And a lot of it goes around a couple passes with the congressional legislation. The flight attendants wanted, and I think there was also some flight crew as well, wanted to create laws to measure cabin air quality and then report that via website. It failed both times, and primarily it was done because of the FAA expert witness. The FAA was the expert witness, and they testified, and we have this quote, "No way of identifying and measuring cabin air quality." So that's a spoiler alert, and this is a little bit of a foreshadowing. So as we research this and what's happening in the cabin, and we see different diversions happening with really specific and measurable health consequences, we can start to calculate the economics of a diversion. What we typically see is for like international diversions, it's around $15,000 or so for a shorter haul single aisle diversion, and maybe well, I'll take that back. It was about $15,000 for international and about $7,500 for short haul, but it adds up, and those are the direct costs. If you start thinking about all the side costs and potentially putting people up at a hotel, it could quite get expensive very quickly. And if we could prevent even one of those diversions, it would be a significant win. Also note that the Delta Flight Attendant Union filed a lawsuit in January on the toxicity of cabin air. That's a big deal. And the lawsuit was filed well before L2 and IP video started working on addressing some of these issues, and also well before COVID came up for that matter. What is interesting to note is that when we compiled the data, there's all kinds of subsequent diversions and aircraft types and a variety of information, but really need to do more research there to quantify it of exactly what is needed. But in the data we do have shows that at least in one case, 7 flight attendants went to the hospital in 2017, and that was after a cabin air directed diversion. And that it seems like people with asthma are a lot more prone to be affected by cabin air events when you look at the data since 1999. Next slide, please. So another example, just last month, an ERJ diverted on a short haul due to smoke in the cockpit. Halo, in its recommended configuration using multiple units in the cabin and flight deck, really could have identified if the smoke was toxic or non-toxic. And that's all improving the decision-making process. Our prudent captain would have probably diverted anyway, just given there was smoke in the cockpit. But, if you have the actual data, should we, how quickly, any information that you get that's available to help with the level of emergency, it's needed, it's required. What to do and how fast. Those are always questions that somebody who's in the front of the aircraft need to find out. So smoke and reports of smoke in the flight deck happen. The takeaway here is the ERJ smoke could have been quantified with 2 active Halo units, both measuring the particulates in the smoke to help guide, reinforce a decision to divert. And those 2 units would actually be comparing data, and we'll be talking about that a little bit later. Next slide, please. So everybody wants to probably know, why is Halo the one? Well, this event in February was particularly concerning as there was reported that there was fumes on board. Now, one, the crew was physically ill and spitting up blood that evening, so that's obviously not desired. And the same aircraft, which is maybe even more concerning, had a similar event 3.5 or so months prior. And we don't know the exact history behind that because that wasn't given to us, but it appears that the same issue repeated. So Halo is one of those systems that would be able to determine and watch the trends on the aircraft. And again, we'll get into that a little bit later. So in this case, the maintenance group did ultimately find oil was getting into the engine, and therefore fumes were able to get into the bleed air system and then the air cycle system, and then that drives right into the cabin. And then you smell it, and if it's really nasty stuff, people get sick. So Halo, we believe, could have identified the problem earlier, and maybe that could have helped them find that there was an engine seal that was bad, that was starting to fail, that maybe you didn't quite smell it, wasn't too bad yet. But these sensors are so accurate that well beyond what a human would smell, they pick up. And if they could have defined that earlier, they would have repaired it quicker, and then they may not have had the diversion. So all in all, the precise data from Halo of what is happening and what is exactly in the air can point to a solution, or at a minimum, eliminate a possible problem. So kind of repeat a little bit, but to give you a takeaway here, there are aircraft smoke detectors in cruises' noses. And you got detectors and noses. And the smoke detectors are for detecting smoke, that's it. And the cruise noses, we all know when we smell something, what do you do about it? But that's not necessarily going to engage quick enough for alert mode. and precious time could pass to gather that data, that situational data. And therefore, without situation data, you can't take corrective actions quickly. A second takeaway is by monitoring and trending air data sensors, which are much more advanced than carried aboard today. L2 and IP video are offering an opportunity for system failures to be addressed in a predictive way, well before an urgent event triggers a diversion level event or alert. Next slide, please. So what's Halo? A classic product marketing and phase review process method, which I also love, defines what the product is and what the product is not. Today's Halo is sold in commercial buildings, schools, universities, just tons of places. And we want to move that now to the aircraft. It can measure multiple chemicals, sounds, atmospheric items, as Dave will go into here in a little bit. The IP video team has a patent pending, and the current product in L2 is exclusively designing, ruggedizing, and integrating Halo for rigors of aerospace use. And then, of course, the next step is to get all the regulatory certifications, and we'll do that worldwide. So the phase 1 version today is not a smoke detector replacement. We covered that a little bit before, but I just want to make sure that's clear. And we are investigating how to incorporate all of the Halo sensor suites and capabilities with the certified smoke detector at some point. And then eventually, because of all the stuff we're reading about now with COVID and so forth, adding a pathogen, contagion detection device. So we also have a vision for using Halo units and their wireless capabilities to transmit other data streams, more than just air cabin quality. It's the wave of the future, and we're moving that way. All forms of data coming off the aircraft will be more and more important. The data is the power. So now I'm going to turn it over to David Antar, President of IP Video.
Mark, thank you. And what a great job on doing an initial introduction. And we're excited to be part of the team and really honored to be involved with L2 in the development of bringing Halo to aerospace industry. To give you a little background on our companies, this is our 30th year in business as an overall organization, and our IP video division started in 1996. But ironically, there was another company that also started in 1996, a company called Axis Communications, who invented the first network-based or IP-based camera, and out of Sweden. And we were their first dealer in the US and first partner with them. So we've really been at the forefront of innovation from the early days, and we continue to do that in both security and now in the IoT space. We're kind of a unique company with a lot of the things that we bring to market in both the AV space as well as the security and the IoT space are kind of our unique things. So with that, in our 20 plus years, we now have over 600 dealers in the US and Canada for our products. And we're really excited to be able to bring these into the aerospace market. We think it's a great vertical market, and we really believe we have some unique solutions that could fit very well into that industry. Next slide, please. So as you can see from this slide, Halo is one of the most awarded products in the security industry and also in the environmental space. We've won over 23 awards to date for Halo. And right now it is truly one of the most awarded products that the security industry has ever seen, and one of the quickest growth models that anybody's also seen going into the security industry. We attended a show called ISC West, which is a large security show in Las Vegas every year last April, and we won Best of Show at that show, which was pretty amazing. There's over 30,000 attendees there, and Halo actually swept the show with over 5 awards, that including Best of Show. And it kind of set us apart and showed the innovation that's coming out of our company with some of the interesting things we're doing. Now we feel it's time to bring Halo and its capabilities to the aerospace industry, and also to have the traveling public realize the benefits of cleaner and safer cabin air. So we're really excited, and I'd like to talk a little bit more about some of the capabilities of Halo. So Halo is kind of unique. It has 12 different sensors that work cohesively together to be able to alert. But when it gives an alert, it's actually using multiple sensors, not just doing it on a single sensor. So right now, one of the big things that Halo has gained a lot of recognition for is its ability to detect vape and vape with THC. We are in thousands of schools in the US, Canada, and even overseas right now in South America and in the Middle East with our product, doing vape detection and vape with THC when they put this into an area of privacy like a bathroom or a locker room. But in addition to that, it also can do advanced smoke detection, carbon monoxide, carbon dioxide detection, methane, propane, natural gas detection, chemical detection like ammonia, alcohol, in addition to VOCs in the air, volatile organic compounds. And on top of that, it has temperature sensors, humidity, light levels, and on top of that, air pressure, which is actually a very valuable component to have as we go into an airline to be able to report on pressure within an airline at whether it's on the ground or whether it's taken off or once the cabin's been pressurized. In addition, it even has something that we've recently added to it, which is called AQI or Air Quality Index. The other side of it is a whole audio analytics side, which does things like, currently it does gunshot detection, keyword detection, where it'll actually wake on a keyword. And the important thing is that it can determine what are normal sounds versus abnormal sounds. It has artificial intelligence and machine learning in it, so it gets smarter over time and starts to know what the patterns are of normal noises that it might hear. In addition to that, it has a 3-axis accelerometer that detects fine movements, but also can recognize vibration and different things that might occur in an airplane and give advance warning for events and different things that could happen from that. With that, we'll move to the next slide. So this slide is an interesting slide. If you look at the picture on the right, it depicts how Halo could work into the aerospace industry. And what it's showing is how bleed air comes off the engine into 3 different units before release into the cabin. What Halo's capability would be that it could do the following things to measure and detect at multiple points in the fuselage, both in the pressure vessel and outside the pressure vessel, things like particulate matters in the air. And particulates come in different sizes, and Halo actually can measure 3 different sizes of particulates that might be in the air. In addition, offenders such as smoke, carbon monoxide, carbon dioxide, ozone, which is coming very shortly to Halo. It was in our roadmap anyway, and we found it's a very important component to have for the airline industry. Vape or vapor, chemicals, volatile organic compounds, each have unique signatures. And what Halo uniquely does is by identifying a signature of a known chemical that might be in the air, we can then either filter or alert on those. So as an example, when we use it to detect vape in areas of privacy bathrooms or locker rooms, we can filter out for hairspray or body spray because we know the signature of what those look like. The more signatures we create for things that might be normal in an airplane, we can start to filter or alarm on those. So that's what makes Halo pretty unique in the things that it does. And then it also monitors the air quality index, and we're going to talk about the AQI in a little bit. I'm going to have Frank talk about that. So with that, I actually wanted to go to a live demo and be able to show you what Halo looks like. And I think you're going to be impressed with seeing a live shot of Halo. So if Danielle gives me permission, and we are going to show our screen. And hopefully you're seeing Halo right now. So what Halo does is gives you some very easy dashboards to be able to understand what's going on with Halo, either for 1 or multiple units. And we have a...
David, this is Mike. The Halo screen you were showing went away.
Okay, let's try that again.
It's back now.
Is everybody seeing it? Are you seeing it now?
Yes.
Good, perfect. Okay, so with Halo, we have a dashboard that we created that shows what's going on with the Halos. And we created color coding of green is obviously normal. When things change to yellow or to red, it shows an alarm. So I'm going to show you the second screen on it right now, which is the graphing screen. And the graphing, what it does, if you notice all of those red arrows are the alarm thresholds that have been preset either manually or they can get preset automatically by the system starting to recognize what's normal versus abnormal. I'm going to do a little simple experiment here to just show you. And I have a can of acetone in my office, and I'm going to actually show you what a little bit of acetone near Halo can create. So you see the VOC is starting to rise in the carbon dioxide, and it just shot it off the scale right now. So that was instantaneous from a little bit of acetone being released into the air. So you can imagine how it shows over time those things before an emergency happens. So typically, it will show those rising levels and alert at the preset points that we have. You can also see how quickly the numbers are coming back down to normal. And I'm going to go back to the dashboard for a second. And if you notice the red on the VOCs and the CO2, those are the alarms. And also the AQI went up to 59 right now, which is the air quality index, because obviously that was affected by these. Also shows the sound levels in the background, shows the VOCs dropping over here on all the way to the right. So it's pretty interesting how it's able to bring all these things together and give you instantaneous information. Halo stores over 1 million data points per day, which is pretty amazing. And as that data gets accumulated and we get baselines, we begin to know what's normal versus abnormal, to know what to bring to people's attention and what would require an actual alarm. So with that, I'm going to bring us to the sensors themselves. And I'm going to ask Frank to join us, if Frank can, for a few moments. And Frank, why don't you talk a little bit about the sensors, and then we're going to turn the PowerPoint back over to you.
Thanks a lot, David. So as David pointed out, we have several available dashboards. The one we're currently looking at is the raw data coming out of the each one of the 12 sensors that we have in Halo. So we have environmental sensors like temperature, humidity, and light level. We measure particulates in the air from 10 microns in size, 2.5 microns, and 1 micron. And these are important measurements, especially the smaller ones. You can imagine you breathing in these particles and them causing respiratory problems, especially those people with asthma would have problems with these. We measure gases in the air from carbon monoxide, carbon dioxide, ammonia, nitrogen dioxide, and volatile organic compounds. We also measure sound and movement of the device. And finally, we measure air quality index. So when you look at this, it's clear that Halo has the ability to measure the cabin air quality, which should really make the FAA happy, because that should allow them to be able to identify these fume events with what's actually going on in the cabin during the flight. So, how do we do that? So it's these millions of data points that David talked about, and all of the combination of these sensors. We look at this data and we put it together as signatures. So we combine all the information. And these fume events are not just going to be one particular chemical. They're going to be combinations of chemicals or absence of chemicals. And these signatures that we identify will allow us to know, is it a problem with oil ingress into the engine? Or perhaps it's just somebody in the kitchen set the microwave on for too long and they burned a dish. So it could provide really valuable information for the FAA and the airlines. The other thing that's really important that consumers are interested in is the quality of the air. And we're going to get into that now and talk about the air quality index. So next slide, please.
Great. Actually, before I give it back to you, I just want to show one more thing. If you notice where it says movement, that's actually the 3-axis accelerometer I was talking about before. I'm going to actually disturb it right now and show you how sensitive that is also. Right now, it's actually sitting on a shelf in my office, and you can see there's still movement because there's vibration from other objects that are around it. But if I go and actually move the unit a little bit more vigorously, you can actually see over there the difference in movement and how sensitive it is and how it can start to create those baselines and show you over time what is normal versus abnormal. So with that, Danielle, if you want to switch back to the presentation.
Okay, one more slide, please. Okay, so air quality index. So think of air quality as a yardstick that measures values from 0 to 500. The higher the AQI value, the greater the level of air pollution and the greater the health concern. For example, an AQ value of 50 or below represents good air quality. You want to see, that level. You want to see green for all the air quality measurements we make. But if you're in an AQI of over 300, well, now you're in a region where it's going to be hazardous to your health. So as you get into that red and purple areas, you really need to be concerned. The air quality is measured into the 6 categories. And as you go through the colors, as you get below green, each category represents the danger to your health. So green, you're good. If you're yellow, it's only if you are sensitive to certain things, like if you had asthma, it start affecting you. Until such point, even healthy people start getting affected. So, it's something that, we need to monitor very, very carefully, whether it be in our cities or in our cabin airs. Next slide, please. This is an example of the kind of data that we collect with our cloud utility. Now, the cloud utility collects data from all halos and all of the data points, all the sensors, all the millions of data points per halo. It collects it into one repository. And with that information, we can start combining maintenance information, fume events, and we can start using artificial intelligence and deep learning techniques to see where the correlations are. So if you think about the power of deep learning and of artificial intelligence, we combine all these millions of data points over, say, 5 halos that are located throughout an airplane. And we know when the plane took off. We know when there's a fume event. We know when maintenance has been done. And we apply intelligence to this. Now we can start identifying the causes of these events and actually start to come up with ways of preventing them. So if we know that we see a certain signature starting to rise, and we know that's caused, say, by a faulty gasket, so what we can then do is we can schedule preventative maintenance on that plane before that actually becomes an event when the airline is in flight. So we can save time, either from flight delays caused by these fume events, or from diversions to other airports, the cost of diversions. We can start preventing these by start analyzing this data and doing such preventative maintenance. So this is just one of the powers you have from using Halo and combining all this information. And with that, I'll turn it over to Mark.
Well, thanks, Frank. So the next couple slides get into a little bit more detail about a typical cabin air system, whether it be bleed air and air cycle systems, that type of thing. But really what we're looking at here is when we're doing the Halo development and optimizing the placement of these LRUs, we've been looking at a variety of different configurations. It's what we do. We're integrators, and we've started to interface into the aircraft systems in a way that provide feedback to both flight crew and the cabin crew. And we'll get in a little bit later about some of the alert modes and things. But here, the real focus is that we've researched and validated a variety of airflow options in like typical aircraft, like for instance, the 737. And we looked at some, they're about 15 years old, at least they're delivered about 15 years ago, looked at some NGs, and now we're starting to look at the MAX, which of course, we all wish they were flying. But as some of you may know, about half of the airflow is often recirculated in a lot of this generation of aircraft. Now the 787 has a dedicated system, it's all fresh air, it's not part of the bleed air system. And you get, high powered fans basically blowing all that air in to pressurize the aircraft. But for the 737, a lot of the aircraft of pre-787 era, we are recirculating the air, and the typical passenger doesn't know that. They just sit there in the seat and they've got a gas barrel over their head, and if they smell something, they don't know where it's coming from. And we have the same situation maybe for cargo people. Even though cargo companies aren't going to necessarily have passengers, but they may have animals and pets. There's a variety of things that we still think that the cargo people need to be able to be considering the air in the holds. Now, of course, the big cargo freight carriers, they could put the system in the above where they put the actual cargo containers, but down below where the baggage is, there's some things down there we're looking at as well to figure out how 1 or 2 Halo systems could actually look at the air quality data and be able to alert that and advise, because you can't otherwise see it. Now, of course, those areas already have smoke detectors, and we're looking at ways of either supplementing those or eventually replacing them. Next slide, please. So sample configuration, we've been looking at different places we could put the units for both detection and measurement. We want to optimize those. And one of the things we're kind of focusing on at the moment is there's a mixed manifold and air gets dispersed. And so we're looking at actually putting Halo units on each one of the inlets as it goes into the different zones within the cabin. And as you may notice in the bottom of the slide, the flight deck itself is actually isolated from the cabin. It's got its own system. Matter of fact, the flight deck does not get recirculated air. It's always very fresh. Now, it's not on this particular diagram, but something that you may be wondering is that on the actual lavs or the galleys where there's air potentially smells, you could outflow that. And so there's usually some sort of port, something close to those areas that can just flow it right out overboard. However, what happens if there's a leak in that system or something's wrong or it's not working right? Then all that smelly air is getting into the cabin. And so what is it? Now, on the lower left, a couple mock-ups of the cabin air monitoring panel we've developed, and that's for the flight deck. At least that's our current plan, is put that in the flight deck. And rather than interfacing to like an ICAS system or something like that, that requires OEMs to provide software updates or service bulletins, those things cost money. They're complications. We're looking to keep the system as completely self-contained as we can. If over time we want to interface it with one of those systems to make it more of a dark cockpit and more alerting, that is something we're going to do. We've done that in other programs, but on this one we're starting out with just a way of getting some panels. Now, there's also talk, we'll get in a little bit later, but there is an app that we're looking at developing that allows us to provide the flight crew this panel, but then the cabin crew something else. The panels themselves, or the Halo units, have a colored LED, and that could be programmed to be green or amber. There's maybe a case where there's a red, even though we're not looking to use red for obvious reasons. But there's also ways of having that flash. It could flash at different rates. So we're not wanting to have anything out there that basically has an oral alert that the flight crew needs to hear, unless it's deemed to be emergency. But we're not currently planning on certifying this product at that design assurance level. So we're looking to keep it as a straightforward panel. You'll actually be able to see status. System will be comparing the different Halos. And then for the cabin, it's going to be more around the app and then the different colors. So next slide, please. So this is a fun slide. What you're seeing here is a proof of concept of Halo. We worked with IP Video, and we constructed 6 of these units that are going to be out and about to try to gather different types of baseline data. The question is, what is and what isn't in the cabin air today? So we'll use these units to support a variety of testing, and we'll measure the baseline of cabin air data. I think that's really what we all want, is baseline it, different configurations, different situations. And we have a couple candidates that are actually looking at putting this on board the aircraft so they can just measure away. But if anybody on the webinar, or if you know anybody that's interested in maybe using some of these units, we will make more. Just kind of a little bit of a side note, these are very yellow, and they're Pelican boxes, and they're much, much larger than what would actually be on an aircraft. This is just a way for us to get the technology that's available today, put it in some meaningful form that could be strapped down. It can be powered up. It actually plugs into 115 volts, and it just basically acts as a carry-on device. Now, the obvious thing as well is if you were to put this into an area, let's say a galley, or hide it, block it away behind a door, you're not going to get the same amount of airflow. So we really do need this to be in where the majority of the cabin air is going. So next slide, please. So this is my last slide, and before we get into any questions, to play off the famous credit card company, what is in your cabin? We've probably told you today what you've already known. There are unknown smells, passenger and crew complaints, There's also a lot of anecdotal evidence of poor air quality. Everybody's asked over the years, is the HEPA filter bad? Did airline take it out to save fuel costs? I mean, it does take energy to have a HEPA filter in there. Is it just way too old? The failure in the bleed air system. You know, what is there? What is the guy up a couple rows up eating? Is it something that he should be eating? Is there a cleaning chemical spill? And just wondering in general, is the smell that you have, is it natural or unnatural? And so what this system allows to do is to do the analysis, gather the data, you know, just do all the trending that you're going to be able to do over time, and you'll be able to know both in real time the severity and also, and I think more importantly, what you can do to actually trend the air quality data and drive and perform predictive maintenance before it's an issue. So now Halo gives you the ability to do just that. So thank you.
Mark, I'm just going to add one quick thing to that also, which is with Halo, and for everybody to see, this is what Halo actually looks like. So this is an actual Halo, relatively small device at this point. Current model is a Power over Ethernet. Actually, it's powered by the network, but this is the only part that shows through a normal ceiling for our commercial installs. But the interesting thing with Halo is how it's being used right now with COVID-19 is a lot of commercial buildings are implementing this to be able to determine when a building's been sanitized with fogging. And we've been hearing a lot with the airline industry looking to do the same thing and be able to fog and disinfect the airplanes in between. This would be the only way to get a confirmation that it was properly sanitized, and it will actually give you the chemical concentrations and the amount of time that they existed on that airplane and an actual confirmation that the work was done. So this could be another interim solution as people are trying to find those COVID-19 solutions to try and bring passengers back and get the airlines back to normal.
Excellent.
Okay, we have some questions that have come in. I'll throw these over to Mark, since initially they look to be aircraft related. Mark, you can ask David or Frank to add to anything.
Well, I will do that.
Okay, from Brian in North Carolina. What does the development schedule look like, and have you already applied with the FAA for the STC?
We'll really kind of have two paths at the moment we're looking at. Path one is more of a non-essential carry-on type device that can be certified. And then the phase two is a DAL-D design assurance level product. We may, as time goes on, get it to a higher level, but our current plan is to do the DAL-D, and that allows us to put it as in the aircraft. We could use it for the purposes that we've been talking about today. As far as getting the STC generated, that's something that we obviously do. It's what we do for a living. And for those who don't know, STC is Supplemental Type Certificate, and that gives you the authority to put an aircraft down for maintenance and actually install a system and then take credit for it. So we're looking at those now. The development schedule itself, I would say, 3 to 4 months for the phase one, and probably, end of this year for phase two, maybe as late as next year. I'm always pushing schedules to the left and then challenging people to try to figure out a way to do it. But I think realistically, it's probably going to be early next year. And a lot of that's going to be driven by the DO 160 requirements, which is the environmental testing you have to do on any product that becomes an aircraft product. And even though Halo has proven itself in rugged situations, we'll have to reprove that in an FAA controlled way, and may have to make some tweaks to that, more so than we originally had planned. Of course, we're going to put all this in a ruggedized package, so that should help it, but we'll have to go through that process. Anything to add, Dave or Frank?
David?
Frank? We're anxious to see this brought to market quickly. We know it can solve a problem, and we're really just going to support those efforts. And as I said, getting those pilots moving sooner than later, and we have some scheduled. We know that it's going to kind of fill up the queue for them, but we'd love to get more of these airborne and start to get more data, because that's what's going to help us to move this whole program a little bit faster, getting that data early on.
Okay, so from Mark in Kansas, what is the expected installed weight of a ship set for a Boeing 737?
Interesting. Well, I mean, we've been talking about internally 15 to 20 pounds. I mean, And I guess that comes up from less than a pound for the actual Halo unit, the way we're talking about now. Actually, it's 0.8 pounds, as I recall. And then by the time you regularize that, we're going to put a little beefy power supply in those. Even though it can do PoE, power over Ethernet, we plan on putting individual power supplies in these units to provide the flexibility to do either or. And so you probably around 3 pounds or so each one of the units, and then you add in the control panel itself. So you're probably talking about 20 pounds, but we are looking at trying to get it down to 15. Everybody knows that, you know, weight is very important to minimize on an aircraft. Even as fuel costs now are relatively low historically, we just can't have extra weight in the aircraft. So we will be pushing that as far as we can to the left.
Okay. From Paul in Washington, do you have ROM pricing yet?
I thought somebody was going to ask that. Well, being this is a public webinar, I can say that we have a not to exceed of around $19,000 per each Halo unit for the certified version. Of course, if you buy a bunch of them, that price will go down, as would it for anything. So by the time you're probably done with the whole system, not including installation, between the kit, the units, let's say you have 5 units, it'll be we're treating about $75,000 for a ship set is what our target is.
Okay. From Ron in Florida, can these be installed in spacecraft to measure their cabin air?
I want to take that one. So yeah, we were actually wanted to get this onto SpaceX onto their latest launch, and we just were too late to come to the conversation. But we'd love to get one of these up in space. We believe there's a huge amount of data that could be collected from it that would be very valuable. And we know they have some pretty cool instruments on SpaceX and some of the other capsules, but grabbing all that additional data from Halo could be very, very valuable to a lot of people. So especially ozone layers and different oxygen levels and a whole bunch of other very cool information that we can gather from it. So we will get one up one of these days. They put a Tesla in space, we'll put a Halo in space.
Ron didn't say who he worked for, but let's hope it's SpaceX or NASA. From Joseph in Arizona, what do you do with the data from this unit, and how do you retrieve it from the aircraft?
Frank, do you want to grab?
Mike, you want to? I could answer that, but I think Mike, you're Mr. Data. Do you want to take a hack at that, and I could add in?
Sure. You know, this has been one of the biggest, surprisingly, I guess, one of the biggest topics when we've introduced this to airlines and the aerospace industry. I think the aerospace industry has clearly brought on to the usage of data and how data can improve things. So to be very clear, just mechanically, the data comes off the aircraft, can do it wirelessly via Wi-Fi network, and it goes into a cloud. The second way, there's always a backup, and you can only do that on the ground because of transmission requirements and FAA restrictions. The alternative, there's always a backup in aviation. We call it sneaker net. Many of you have heard that term, which means that if you can't get a handshake wirelessly via Wi-Fi, a technician could go out and just download it with the SD card, which is in every unit. The ability to get it wirelessly just, of course, minimizes touch time. There are lots of different things that are operating wirelessly today. Some of them are operating via cellular module, and we're investigating that to use a cellular module to transmit as well. There are many QARs that are all over the world flying around. Many of those have a cellular module and transmit every day, every flight. So that's a key part of Halo, is one, the ability to record and capture this data, and two, wirelessly transmit it. Once it can capture this data, there's no barrier outside of storage to have additional aircraft flight data or aircraft health data sent to a Halo unit to be aggregated and shipped off when the Halo cabin air data is transmitted. So there's lots and lots of opportunities here to compile, aggregate, converge all of these data streams into one for another way of getting data off of an aircraft.
All right, Mike, I might add a little something to that too. You know, our ideal would be to have that they have real-time alerts coming from Halo that could be broadcast to the ground. And not just where, you know, the pilot has information, where they could actually broadcast some of that information. Not necessarily full data, because, you know, you'd rather just do that when you can do an upload, but just the exception data as it starts to get smarter and learns for that machine learning. We want just that exception data being transmitted to somebody so that they have external eyes on it and potentially, you know, go over the Wi-Fi network that's on the existing aircraft.
Yeah, if I could just add, we designed Halo to be very economical in its data and what it transmits over wireless. So, you know, we could do it, you know, in flight, you know, over a satellite or LTE type network, or we could do it as when the airplane comes into the airport and connects wirelessly. It can be done either way. There's plenty of storage on the Halo, and it'll just be how real time you want to look at the data. And both can be done because of the way it's designed and how economical it is in transmitting useful data.
Frank, I think we configured those yellow POC, proof of concept boxes, to have storage for 8 days based on either 8 or 10 flights a day, as I recall. So
Yes.
it won't overwrite until 8 days. Is that
That's
accurate?
correct.
One of the other things which we really didn't mention is Halo was built as a very open platform from day one. We've been in the security space, and a lot of people claim to be open, but they don't really do it. This is really, really open from the ground up. We built a community of people that have done integrations to Halo, from video management platforms to building management systems. We just completed our BACnet integration, which allows us to talk to building management systems, to lighting systems, to door access systems. So Halo was built from day one to integrate to other systems as a very, very open platform. So the whole thing about it is just to find other things to integrate to, and it kind of is the poster child of an IoT sensor. You know, it really is the true poster child of what open IoT means in the enterprise world.
Great. Thank you, David. We're coming up on 1:55. Let's take one more question from Rob in Iowa. Has it been tested in aircraft yet?
I could take that. This is Mark. Short answer is no, but we are really working to get that baseline data. We really need the chemical, you know, noise, vibration, all the different things that the product could do. We also want to focus on the atmospheric side of it. So we need that test data. That's something that we're spooling up to do. We want to get that done as soon as we can. If anybody, as I mentioned a little bit before, if anybody has an interest, we'd like to set you up and then get the data off. We'll analyze it. Either you could analyze it some on site, which we'll have to learn a bit more about, or we can provide reports back.
Mike, you're muted.
Super. There you go. And hit the button. This has been fantastic, gentlemen. Thank you for your time, your expertise, your willingness to tell this story of how we think we can create healthier cabins, to create the healthiest environment for airlines and their passengers. They want their environments to be as safe as possible to get the traveling public back flying again. So thank you, everybody. And thank you for the the attendees for spending some time with us today. And please write us. You have the emails here. If you know of us, give us a call. We'd love to talk to you about this. So David, Frank, thank you. Mark, thank you.
Thank you. It was our pleasure. Have a great day.
Bye-bye.